Hello, ma'am. This is Lara Sushmitha. My topic is about general relativity. General relativity is also known as general theory of relativity and Einstein theory of gravity. It is geometric theory of gravitation published by Albert Einstein in 1960. It is a theory of space and time. It is used to predict things such as existence of black holes, bending due to gravity, and the behavior of the planets in their orbits. The history of general relativity. It is developed between 1907 and 1915. In 1907, published first paper applying SR to accelerating reference frame that also predicted gravitational time dilation. In 1911, published paper predicting gravitation lensing. In 1912, Einstein was focused on formulating a theory of space-time that was purely geometrical. The beginnings of GR germinate in 1907 with Einstein thought experiment concerning a free falling observer that he called the happiest thought of his life is for an observer falling freely from the roof of a house, the gravitational field does not exist. By 1915, Einstein has developed what are known as the Einstein field equation. G mu v equals to 8 pi g by c power 4 into T mu v. The general theory of relativity published in Annalen der Physik in 1916. The motivation of general relativity. General relativity or GR was created in order to better understanding of gravity. It was helped us to answer why gravity exists. General relativity has many predictions, most of which have been verified by experiment with an accuracy. The special theory of relativity encompasses inertial frames of reference moving at uniform relative velocities. Einstein asked whether or not systems moving in non-uniform motion with respect to one another could be relative and came with idea of general relativity. The equivalence principle of general relativity is the fundamental underpinning of general relativity. It says that there is no experiment that can be done in a small confined space that can detect the difference between uniform gravitational field and equivalent uniform acceleration. Some predictions of general relativity are geodetic deviation, frame dragging, gravitational lensing, black holes, gravitational redshift, gravity waves. Geodetic deviation is it arrives from the transportation of angular momentum through gravitational field when EFE are applied to a massive body. Massive bodies like Earth warp space-time and a spinning object that is gyroscope orbiting the layer would be exhibit a precession of its axis of rotation. Frame dragging. Frame dragging is derived by Hans Thrying and Joseph Lindsay. Rotating massive bodies pull space-time around them. Frame dragging measurements is a current data analysis yields 15% statistically uncertainty, hoped to be down to 1% by 2010. Gravitational lensing effect. The gravitational lensing effect occurs when light reaching an observer has passed by a very massive body which is heavily distorting space. The light can be seen to bend around the body. Black holes. Does they exist? For sure. Black holes are detected by either their gravitational influence on nearby bodies or through electromagnetic induction. Black holes have the most profound prediction of general relativity. A black hole is a large body of matter that is so dense that nothing can escape its gravitational attraction at a given distance, known as the Schwarzschild reaction. Rs is equals to 2gm by c square. Gravitational redshift. The gravitational redshift occurs when light leaving a massive body redshifts in order to conserve energy. Light can be also blue shift, it falling into a gravity well. The appropriate equation of the redshift is hf is equals to hf plus hf into gh by c square. It is measured accurate to within 0.02% of the predicted value by the Pound and Repka in 1960 in the tower of Harvard University. Gravitational waves, the fluctuation of a space-time curvature that is propagated as a wave, radiates away from the accelerating bodies, carries energy away from the source. It predicts that two massive bodies rotating about their center of mass will lose energy in the form of gravity waves and the orbit will decay. Thank you for giving this opportunity.